How do you keep kids entertained during quarantine? Like this. Shout out to Period 4, who gave me the awesome idea of wearing the most random of clothes possible. I hope I met that challenge. I have on this awesome beanie, which you could clearly see why I don't wear beanies because I have an unusually large head that is in the shape of a perfectly round melon. Next, pink scarf because you know it's cold. Disneyland jingles. Tie-dye pie, Hawaiian shirt. And then I had one more special request. Miss Parks, wear socks on your hands. Well, it didn't work with this hand because I can't write and I can't fix things here, but I do have a sock on this hand. So thank you, Period 4, for this awesome idea. Notice I do have Hufflepuff on, represent in the house. Gotta represent. What do? You gotta keep these things entertained. And if it makes you laugh, that's good. If I have to look like an idiot at your beck and call, I will do that to get you to watch these and to get you to do the homework. I also have my shades on because it's bright in here. So it's bright and it's cold and it's sparkly and it's jingly and it's, tie-dye pie and let's just do this. All right, here we go. 7.4 today is going to be in 2 parts. I can't really do 2 over here because you can't see that, so I'm going to do it on this hand. Funny thing is, I did have a sock. I had one of these on. It just wasn't working. So sorry, dude. I tried. So again, this video, 2 parts, 7.4. The first part is going to all be about classifying. And then the second part is going to be about how to approximate a square root and some examples of that. So please make sure you watch both videos on 7.4. Even though there's only homework for 1 lesson, there's 2 videos you got to watch. Here we go. When we classify numbers, what we are doing is we are putting numbers into categories. And the way that I do that, I think about the real family as a family tree. This is how I classify. There's all kinds of ways you can do this. And for me, I just kind of thought of this idea because most people understand a family tree. Some people do not, but most people I've found, they do. So I'm going to do it that way. So the real family. Star them. We're going to classify real numbers today. So here we go. The real family had 2 kids. They had, over here, rational. And then, over here, they had irrational. Some basic descriptions. An irrational number cannot be written as a quotient of 2 integers. Now, what that means is basically a quick way of thinking about that. You cannot write it as a fraction. Can't be written as a fraction because you do not have an integer in the numerator and an integer in the bottom, also known as your denominator. So if irrational number cannot be written as a fraction. So examples of those. Examples. Well, world's most famous irrational number. Pi is the most common go-to irrational number. You could have something like the square root of 7. And actually, the square root of any non-perfect square... I tried putting I see sock on my hand. Anyways, the square root of 7. And actually, the square root of any non-perfect square will be irrational because when you take the square root of non-perfect squares, the decimal goes on. There's no pattern. It doesn't repeat. That kind of a thing. And so other examples, well, if pi is going to be irrational, then anything you do with pi would be. So maybe like negative 5 pi. That would also be irrational because pi is irrational. Then you multiply it by 5. Therefore, you produce an irrational number as well. So square roots, and since chapter 7, we did some square roots and cube roots. So anytime you take the cube root of a non-perfect cube will also get you an irrational number. So these are examples of irrational numbers. Now, the irrational numbers, this guy, the real family, did not have any children. But rational did. So here we go. So if irrational cannot be written as a fraction, rational can be written as a fraction. And I will write notes and I will put them up so you can put them in your composition book. Can be written as a fraction. Meaning you have an integer over an integer. And actually, I think I like that go-to quicker. Because anytime you say you can't write it as a fraction, well, you can throw anything over 1, but remember, it has to have an integer as a numerator and as a denominator. So think about a rational number as an integer over an integer. Okay, here we go. Now, the real family, think of these as grandparents. Rational is one of your parents, and irrational is like your crazy aunt, your crazy uncle, something like that. Okay, so it's your grandparents and they had 2 kids. Now, rational is going to be one of your parents, whether it's your mom or your dad. That part doesn't matter. Now, rational had 3 kids. Now you are one of 3 in your household. Some of you guys already are, so you already know how this works. Now, the first kid they had is integer. And we've been talking about integers a little bit more lately. And if we're in class, I'd say, guys, what's an integer? I'd be like, what's over there, guys? And you'd tell me, ooh, positives, negatives, and zeros. And that's what integers are. Integers. So negatives, 0, and positive. So examples of integers. ... Remember that goes on continuously. -3, -2, -1, 0, 1, 2, ran out of room, 3, ... So those are all examples of integers. Now that is going to be the oldest child from rational. The next child is whole. Now, would I actually name my children integer and whole? No, not at all. It's kind of weird. But for this case, let's hope this helps. This is how I classify numbers. So whole came along. That's that second child. And what whole numbers are, because sometimes in class I'd ask you guys, what are integers? They'd be like, oh, integers are whole numbers, Miss Parks. Are they? I don't know. Yes, no. Maybe? Well, let's figure this out. So whole numbers are actually numbers that have 0 and positive in them. And they're going to start out with 0, 1, 2, 3, ... Notice the ... doesn't go on down here. It only continues on when it's positive. So whole numbers are like integers, but they do not have those negative numbers in there. Can't really see my eyes. And the last child, because remember, when your parents are rational, whether it's your mom or dad, doesn't matter. They had 3 kids, integer, whole, and natural. And this is the part that I miss the most about not being in class with you guys. And I look like an idiot, by the way. I keep catching pictures of myself. I look like an idiot. Oh, wow. In class, I would say, guys, start counting. Most of you guys would be like 1, 2, 3, blah, 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 blah. And as long as I've been teaching, there have only been maybe 3 or 4 kids, maybe 5, maybe 7, okay? They would say 0, 1, 2, 3. But natural numbers are also known as counting. So AKA counting numbers. Which you start off with 1, 2, 3, ... Now when you count, do you start with negatives? No, not unless you're a weirdo. Which, you know, some of you may, not that you're weird. But also, here's how I think about it. And this is when I wish we were in class. I'll start off by saying, guys, natural numbers occur. And they're like, what does occur mean? So I'm like, all right, guys, how many dragons do we have? Well, there's no dragons. I'm like, right, because they don't exist. And then, of course, the whole Game of Thrones fans would go on, but that's okay. And then I'd say, how many pine trees do we have out our window? You'd be like, oh, Miss Parks, there's 5. Cool. How many chocolate chip cookies do you have? How many pens do I have? And so when you think of a natural number, you want to think of something that occurs naturally. It occurs in nature. Meaning, if it exists, it will be natural. But since dragons and dinosaurs don't exist, they are not natural. Did dinosaurs exist? Yes, they did. But they don't anymore. They're gone. So they're not natural. So if it exists in nature, if it occurs, then it's going to be something natural. Also, these 3 kids, if you look at my examples of numbers, what do you not see in those numbers? Hopefully you said no fractions, decimals, or percents. No FDP. So when you classify numbers, fractions, decimals, percents, they are not part of the rational system. So here we go, family again. The real family, it's your grandparents. Your grandparents had 2 kids. Irrational, that's like your crazy aunt, your crazy uncle, you know, the one that's like always the fun one at the party. I'm the fun one at the party, in case you didn't know. And then rational would be like one of your parents, whether it's your mom or your dad, it doesn't matter. And so they had 3 kids in this order: integer, whole, and natural. And we're going to work on classifying them to figure out, well, if something is this, does that mean it's also one of these other categories? And so we're going to work on that with this next example. And in your book, they use Venn diagrams with circles. And to be honest, I never quite understood them. They're kind of hard for me to figure out. And that's how I came up with this family tree. So here we go. Example 1. I'm going to do this on the back because I'm going to keep reverting back. Example 1. Classify. All right. Here we go. Let's go. Square root of 17. First thing you want to ask yourself, is this real? Yes, it is, because everything you guys study this year is real. Now, the opposite of real is something we call imaginary, and you're not going to deal with that until you're in Algebra 2. So anytime you classify, the very first thing you want to write down is real, because all the numbers that you will ever study right now are real. Because that's where we start. Now next, you're going to ask, is it irrational or rational? Well, if it's irrational, that means I can't write it as a fraction. Well, square root of 17. Is that a perfect square? No, it's not. So since it's a non-perfect... You get my little sock puppet. So since it's a non-perfect square, that fits into our category of an irrational number. So real and irrational. Now, since irrational didn't have any more kids, not anymore, they didn't have any kids, you're done. You're done classifying these. Because irrational didn't have any kids, so there's no more subcategories to go from irrational. So you're actually done with the square root of 17. So when you classify the square root of 17, you are saying it is a real number, which everything is, and an irrational number. Let's do another one. Let's go negative 0.25. So something that's negative. We're going to start off. Is it real? Yes, everything is real. Real. Next question you want to ask, can I write it as a fraction? That'll cover rational and irrational. Well, irrational says you cannot write it as a fraction with integers on top and bottom. Rational says you can. Well, negative 0.25. So negative 25 hundredths. Meaning negative 25 over 100. Is that a fraction? Yes, it is. So it's rational. Next, is it an integer? Well, it's negative, but remember, no fractions or decimals, so we are actually done. So negative 0.25 is real and it's rational, and we are done with that one. Here we go. Next one, I'm trying not to erase too much on the back. Let's go, where are we at? Square root of 9. More squares. We're going to start off, is that a perfect square? And hopefully you said yes, because the square root of 9 is actually 3. So you're actually classifying 3. Kind of tricky on that one. So when you see a square root symbol, also known as your radical, that's the technical term, double check it and take the square root. Don't double take it. Take the square root, and that'll give you an idea of what you're actually trying to classify. So we're going to classify 3. Is it real? Yes, everything is real. That's your first answer on everything. Now, integer over an integer. Well, 3 is an integer? Yeah. Is 1 an integer? Yeah. So guess what? It's real. It's rational. Is it an integer? Positive, negative, zeros. Remember, no fractions or decimals or percents. Yeah, it's an integer. Wah! Almost lost my board. Is it a whole number? 0 or positives, no fraction decimals? Yeah. It's whole. Is it natural? Can I have 3 chocolate chip cookies for dessert? Yes, it's natural. So, it is all 5. And I always want to make sure you go in order. So go top down. They'll make it a little bit easier. Let's do another one. Let's go 72 fourths. I'm going to try not to switch the board. So 72 fourths. Is it real? Not even going to answer that. Is it rational? Can I rise a fraction with an integer over an integer? It's already a fraction. But what are we really trying to classify? 72 fourths. Let's divide that. So 4 goes 1, 2, 3. So we are actually classifying 18. So again, they tried to trick you. So when you get a fraction, divide it out. But also, since they gave it to you as a fraction with integers, it is rational. 18, is it an integer? Negatives, zeros, positives, yes. Is it whole? Wholes are zeros and positives, yes. And can I have 18 kids get A's? Yes! It's natural. The natural part of that was you guys. So again, it is all 5. Okay, last one. Let's go negative 16. My favorite. And no board switching. What's the first one you wrote down? Next question. Can I write that as a fraction? Integers on top and integers on bottom. Yes. So it's rational. Is it an integer? Is it a positive, negative, or 0 with no fractions or decimals? Yes. Is it whole? Whole numbers have 0. I look like an idiot when I do that, but that's okay. That's what I do. Zeros and positives. So no, negative 16 is not whole. And if it's not whole, it's also not natural. Can you have negative 16 slices of bacon? No, you can't have negative slices of bacon. Which, by the way, who would ever create such a thing? Because if you're going to have bacon, you're going to have bacon. You're not going to have negative slices of bacon. I had bacon for breakfast this morning. Fantastic. So, negative 16 is real, rational, and an integer. When you're classifying, let's go back to over here. Kind of a quick way you want to do this. Always go top down. So always start with real, because everything you're going to write is real. And then you go rational or irrational. Once you figure out if it's irrational, you're done. If it's irrational, there's no more. They didn't have any kids. There's nothing else you can classify it with. But then you're going to go down from rational to the 3 kids. So if it's an integer, if you say yes, then you have to keep going. But if you get down to integer and you're like, no, it's not an integer, then that means it's no for the other 2 underneath as well. But if you say yes here and you say yes here, you then have to go to here and find out if it's natural or not. So you can go yes here, but that can be a no. So basically, you want to go from top down, and as soon as you hit no, then everything else is no below it. But if you said something is whole, and this is the last time you said yes, so, let's say 16, because I like 16. If you said 16 is whole, that also means that is also an integer, and it's rational, and it's real. So the last time you said yes, that means everything above it, it is also included in those categories. So if you said yes, something is an integer, but then you stopped. So if you said yes to integer, that means it's also a rational, and it's also a real number. So the limit you can, the minimum you can have is 2. So real and then either irrational or rational. 2 numbers can't be rational and irrational at the same time. You just can't do that. But as soon as you say no to one of these, then everything below it's going to be no. But when you say yes, that means everything above it means it's also in that category. So I hope that helped a little bit. I don't know. So that is part 1 of 7.4. Part 2 is coming up. Have a great day. Hope you guys are well.